We are Lightspeed, and this is our spaceship. The ship will be assembled in low Earth orbit with 3 separate launches from Earth. Launch 1 will send up Module A and the main satellite. The hexagonal prism body will have a height of 4 meters. There will also be a 2x2 docking port on each face. The solar panels on top will have dimensions 2x8 meters. The main thruster with RCS on the bottom will have a radius of 2 meters. There are also 2 sets of magnified tracks 1x1 by 3 meters. The main satellite will have high efficiency solar panels of 3.5 by 4 meters. There will also be a small thruster, 1 meter in diameter. The Aster detectors will be integrated into the main body in a 1.75 by 1 meter box. When getting into low Earth orbit, the satellite and Module A will be physically separated to prevent module damage. Launch 2 will consist of 2 Module Bs and 3 microcommunication satellites. Module B will have a length of 10 meters, including the docking system. It will have a diameter of 4 meters. It will also have thrusters and RCS, 1 by 0.5 meters. There is also a solar panel array and enhanced suspension. The microsatellites will be 4.5 meters by 4 meters and will use the same energy and propulsion systems as the main satellite. Launch 3 contains the nuclear reactor and fuel tanks, which will have diameters of 8 meters and lengths 10 and 8 meters respectively. Phase 2 involves assembling the ship in the way shown. 4 astronauts will be transported up in Module A in Launch 1. The ship will be in a prograde orientation and perform 2 different escape burns at the periapsis. It will make full use of the Oberth effect and use a Hohmann's transfer to rendezvous with the elliptical orbit of the asteroid, reducing delta V. Due to the irregular shape and low orbital velocity, we have concluded that a stable orbit is not possible. Our satellite will be in a pseudo-orbit performing correction burns to stay 500 meters above the surface. Our main propulsion system is a nuclear engine that produces a superheated hydrogen exhaust. The fuel tank also doubles as a turbine generator with a lead bismuth eutectic coolant. All modules will have solar panels that can be used in darkness and EVA. Pressure and temperature will be maintained at 1 atmosphere and 298 Kelvin. Early warning system for solar flares will involve shutting down all power for 5 seconds to prevent electrical damage. Astronauts will work out 3 hours a day to maintain bone density. To evaluate mining sites, we'll use mass spectrometry, moles hardness tests and reactions with metal aquaregia.
Consumable tablets containing omega-3, vitamin A and C will help to reduce the effects of exposure to ionizing radiation. Omega-3 also aids in maintaining bone density. Foods rich in nutrients and minerals will be packed as MREs.
The auxiliary power unit will have energy stored in a solid-state battery on all modules with a glass ceramic electrolyte. Primary fuel on all crafts will be a liquid hydrogen and oxygen due to its high vacuum efficiency. Hydrogen peroxide doubles as a monopropellant for the RCS and life support. It can be broken down into water and oxygen using a platinum catalyst.
At Lightspeed HQ, we like to take pride in astronaut safety and innovation. Over here, we're printing the most cutting-edge technology to ensure that our astronauts live a long, healthy life.
We're going to do this by using adaptive materials. A lead-boron alloy will be used to scatter gamma rays and absorb high-energy neutrons. A graphene sheet acts as a breach detector as the current drops when it occurs. Aminopropyl methacryamalide is a self-healing polymer used in the walls. Module A will have a vacuum toilet, a gym, an EVA port, and a mission control. Module B will have the sleeping pods and a remote control room to drive and conduct tests.
The Aster sensor is an imaging instrument satellite. There are 3 telescopes which consist of the thermal infrared, shortwave infrared, and visible and near infrared. The satellite will use Aster technology to survey the surface of DA 1986. This is detecting reflected solar rays and thermal infrared waves. High reflectance suggests high metal concentration in the region.
Mining could be done by scraping the rock and using a canopy to catch the scraps and dust. Iron and nickel can then be separated using just magnets, and then the rest can be collected separately. Metal can be transported using a maglev with the nickel on DA 1986.
Modules A and B can tessellate together to form large colonies. An Aldrin cycler could be used to transport masses of people of major radius 170 meters.